Hey, this is Steven from Legit Tutorials and the Green Engineers, and welcome back to the DIY metal mill. This is, I dub it the Green Machine Mill. This is episode 2. So I have kind of two simultaneous, I guess you could say, series going on at once. I have the DIY metal router, and I have this guy here, which is the mill, the DIY metal mill. Now, again, I'm pretty much going to be uploading almost a video a day because I have so many backlogs. If you look here of other videos, so I'm just going to kind of keep it going. And obviously, these stuff are for the Green Engineers business, but I like doing this kind of stuff to show you guys how this stuff works and all that kind of jazz. So we go in here, you can see I have so many different projects that I've done. This is just the programming ones. Where's the rest of them? Where'd they go? They're in here somewhere. Oh, product design. So, yeah, I have all these. So this one I haven't. So I got a whole bunch of these that I have to publish. Some of which I didn't finish, and I'll probably go back to and finish. Obviously, I'm not going all the way on each of them because some of these are actual products, some of them are open source kind of stuff. So, the open source stuff, I'll go most of the way, if not all the way, but if it's my own product, obviously, I'm not going to go all the way because, some of the stuff might be protected as far as competitive advantage. But some of these products I do plan on basically releasing pretty soon, like the EcoBase 3D printer. What else do I have here? The shredder, obviously. That I've made one physically. It's sitting right here on the table, so that's pretty cool. Fill Factory is another one, but I think I don't know if I did it all to the point where I'm at now, because I did that for senior project. I don't think I was able to finish that. Anyways, yeah, so we have a few here, and so yeah, basically I'm gonna upload. I have plenty to upload where I could upload at least every day of the week. I'll probably some days I'll probably not actually make new content and then just upload old content. And eventually, by the end of this year, I'll probably have all the other content over the last year or so uploaded. Anyways, so let's go back to this Green Machine Mill. So basically, I have a few different things that I'm also uploading a video right now, today's video. That's the DIY Metal Router 11. And these are all old tags. I can do that later. Anyways. So basically, I have this one and then the DIY metal router. So the DIY metal router is designed to use a high-speed, small end mill with a semi-rigid machine to cut these different types of materials, mainly to make my shredder. Now, obviously, with that, the requirement is that it is a high-speed spindle with low runout using an R8 collet or whatever collet. Most of them are R8 with very low runout. And because of the horsepower required and the weakness, they're not really super hardcore bearings in that thing. And also because it's high speed, the louder it is, generally speaking. The idea is that was going to work, but I'm going to have to use a fourth axis. So now I've actually come across something to also kind of push me to develop the Green Machine mill in parallel. So we're getting close to the end of finishing designing the DIY Metal Router 2, and obviously I designed a DIY Metal Router 1, which I believe was very similar, but I think I used rods where the square channels are stronger. So I came across a new update here. Let me go ahead and find this here. So there are a few. I always forget what it's called. But basically, I could show you. I know that there's this one company that does make it. I'm not necessarily going to use this one, depending on the cost. I might, because of a few different good reasons. So basically, let me go ahead and show you a video. I think a video would be best. Okay. Yeah. So, I mean, this is basically what we're doing here. And then this is using, obviously, so this is a Seiko. I'm not exactly sure if it's recording the desktop. Anyways, so this is a Seiko, what they call a disc mill. So basically what it is it's a side cutter that you could use on a vertical milling machine to go into the side of the part and actually cut on the side. And it has these carbide inserts that whenever an insert goes out, you can just pop a new insert in. You don't have to buy the whole new disc. You just have to buy the carbide inserts, which I think is a good deal. Because each of these discs, if this was a solid disc with carbide ends on it, it would already cost about $100 each time you change it. Here, you might be able to get it for like maybe $50, $60 if you change it over time. But another big thing is that because this is so big and it has so many cutters, that it's actually split pretty well the load between all the cutters. So you'll see here, this is kind of what I plan on doing with it. So this is a 100 millimeter, so this is a big cutter. It's 100 millimeter and it's probably, this is probably how tall it is, 2.5 millimeter. And then it's doing a 1/2 inch depth cut here. So this is a 2.5 millimeter slot, and basically what it's doing is exactly what I want to do. It's going down the material and cutting a slot. And you could hear on the video, I don't know if you can hear on the video, I don't know if it's recording the desktop, but basically it has very little vibrations. It's pretty quiet and yet super precise, right? And obviously super quick. So let's see here, not that one. He's parting here, which is usually probably what these tools are made for the most part. So here he's doing 250 meters per minute, imperial, 718 surface feet, 1/2 inch, and about 100 thou. He's doing 6 thou per tube, which is a pretty high feed rate. So this is probably going at maybe 15 inches per minute, or maybe even 20 to 25 inches per minute. So he's really moving, and that feed rate, you're going to require a lot of horsepower. So this is basically the, let me go ahead and turn it down. So this is basically the alternative to using that 4th axis, because that 4th axis is going to cost me about maybe another couple $100. We can look on it on there. So already it's going to cost me a couple $100. That's number one. Number two is the G code is going to be a lot harder to do. That's number two. Number three is that it's going to take way longer. And also because it's a 1/8 cutter and you can't just replace the teeth like this one, it's going to require a lot more expense as far as tool wear because it's a small cutter. And actually, now I'm thinking that I could start making it out of stainless. So I could basically start making it out of stainless and basically have this cutter go in and cut it. But obviously, if that's the case, this you need a lot of Z clearance. So a desktop router no longer works. So basically, what would work the best is to use, here's another, something similar where this cutter diameter is 5" and width is 1" So this is a big cutter. And here, metric, so 540 surface feet. He's taking 9 thou per tooth. So again, pretty high feed rate. I mean, obviously I could drop that down because again, we are not going to be working with too much horsepower here. So you can see, oh, he's taking a deep depth of cut too. He's almost taking a 0.1 inch. I highly doubt that. I doubt that thing's 0.1 inch tall. Oh, it is 1 inch tall. Okay, so yeah, he's taking a 0.1 inch depth of cut then. That's way bigger than that, but that's just my opinion. Yeah, that's way deeper than 0.1 inch. Anyways, so yeah, here's a better idea. Obviously, this is like 4 times larger than I'm actually looking to do, but you could see kind of the speed. So if I could get something that is a 1/4 inch thick and be able to go into the material and go around maybe 2-3 times at 5 inches per minute, 6 inches per minute. Preferably, I do a whole rotation in a minute, so that would be 3.5 times pi, which is like, let's say 10, so 10 inches per minute. If I can do 10 inches per minute on a low feed rate with horsepower and a half, I'll be able to do this thing probably in twice the time. And obviously, because this thing is not horizontal, and now I can have it vertical, it's going to save massive amounts of time. Because I have this clearance for more stuff to be on the table. So I could basically load this table up with these vertical shafts for the shredder. I could load this thing up with these vertical shafts and also load the rest of the table up with parts as far as the sidewalls, the front and back, and the left and right, and then also with the half moons. So I could load the rest of the parts up and be able to do it all on one table with it sitting vertically, no need for a 4th axis. I could add a 4th axis, but this is not required, and it'll last longer, it'll go faster, and it will decrease my time. And for some stuff for work, if I do continue working, obviously that's I'm leaving in October from Applied unless the freeze goes away, but chances are that's probably not going to happen. So if the business doesn't take off, then yeah, I might go back if they call me. But if I do start my business and it does look good, it would be nice that if I hit a low spot, I could do some machining for Applied, just to make sure that I keep the business afloat. And this machine, a VMC, the green machine mill, I think would be a way better machine to have on standby when, let's say, I don't have any shredders to sell, or my 3D printer is not selling, or or I don't have any laser work, or I don't have any 3D printer work, or whatever. So my 3D printer is not selling, my shredder's not selling, and the fill factory is not selling. Then I have a machine like this to sit by, that's sitting by and waiting for me to do something with. which I am a pretty big fan of. So I think that if, obviously it's going to take up way more space, this is not going to be able to fit on the table, but I have a specific spot that I'm thinking about doing, putting it, which is basically where one of my toolboxes are right now, which means I probably would have to take my toolbox and put it somewhere else, or hide it or do whatever, or sell it, and I could always sell it, you know. Toolbox is not that bad. I could just go and buy one. It's one of my dad's old Craftsman, which originally he wanted to give to me, but still, that's okay. And so here an example of kind of something similar to what I want to do, but not exact. So here it looks like he's doing a 4th axis. I watched a little bit of this video. You can see he's got this housing thing, and he has all these parts. He's got these bellows. So I think it's like 300, yeah, about 600 pounds of frame. Decent sized bed. Obviously, I want to maximize the size of bed that I could get. And again, I explained why this is not as good as far as usage compared to the vertical mill. I mean, compared to the router, because of the lack of space. Because you had to get the full travel on this side as well as this side. But the rigidity is way higher on this than on the router. And that rigidity is what I need to do to get that kind of cut finish that I'm looking for on stainless, right? And then using stainless, you definitely need to have the rigidity to take a deep enough cut that you're not destroying the cutter, right? So, but this is very similar to kind of what I want to do. Basically have these, very similar to what I was talking about, where we have a steel column go up the middle, and then we have basically these, so a steel column going up the middle, and then these things. So I think this is also kind of, it's almost like an i3 3D printer, and then he's got this big basin, but he's spending a lot of money as far as like he's got these servo drives, which I think are like $1,000 kit for 3-axis and all that stuff, which is pretty excessive. But I'm thinking that we could still use all the similar parts that we were talking about in the first series, and he does have some very good rigidity here, but I'm thinking that I like the... So here what he did do is that because this gantry is like this, this is not really a VMC because it has this back and forth motion here. This is probably still extremely rigid because it's actually this that moves up and down, but still this could have that shakiness because it's cantilevered down. I would probably still go with the VMC style and optimize it to get the most space out of what I have. And basically there's the side of the garage that this could go in where it won't be out in the middle of the floor, and I could have a nice housing around it, and then I could reclaim some more of the table space as storage and for other machines like the 3D printer, vacuum former, plate press. So I have a lot of machines that have to go in there now that I think about it, because I have this the sheet press, I have 3D printer, I have a vacuum former, I have my laser cutter all fitting on this table, and it's only 96 inches long, right? And an arbor press as well, and then have at the very end have a opening cabinet where I have to have a MIG and a TIG and maybe even a plasma cutter in there. And then eventually I do want to build my water jet, which I do have the pump for, so I need to do that as well. But that is kind of on the side because I think that this is a way better idea to have these parts fully assembled so you pull it off and it's already ready to go. And then again, so let's go ahead and look at kind of the... I wonder why this guy never did that. Anyways. What was this guy's name again? Finang something? let's just do this. This guy's pretty good. I mean, obviously he got rid of his Skyfire. So again, the Skyfire, I got quoted like 10 grand for one of their machines. Obviously, that's not something that I have. It does have the tool changer, and it does have the really nice spindle. But I have a few ideas that I want to do. Number one, don't have the spindle sticking down so far. Put the spindle up in here so it's not cantilevered down so far from the rails. That's a really long way away from the rails. I like the Umbrella ATC. That's really, really nice. I think he has the the SVM1. So I was looking at the smaller one, really small table size one. Couldn't take as deep of cuts, and he mentioned that. But, you know, it's all about kind of rigidity and how you design it. Mass does help because mass does dampen it changes where the natural frequency of the machine is going to be, and obviously chatter or any sort of vibrations what kind of destroys the surface finish on your part. So Defang Skyfire CNC, I think that's his name. Yeah. And this is basically the manufacturer of these Skyfire machines. So here is SVM2, and here he's going feed rate. So this is 10. So what is that? That's like 100 inches per minute. Are you sure about that? He's going 4,000 RPM. So yeah, let's go ahead and run. Let this run in the background. So yeah, so I do kind of like this and this guy. I would rather have inside. Getting chips up here, not really the best idea. Have that inside. Also, it's kind of in the way. I do kind of like the housing, but obviously here you could see kind of the space. So obviously this, and have an enclosure around it, and you have to have a lot of room around this thing for the bed to move around. And here you see he's got a fourth axis, a harmonic fourth axis, which are about $1,000 from these guys. But you could see how much space that would take up if we had that rod sticking out. You could only do like maybe one. You could have it maybe the other side, and then you could have like a few pieces underneath. Now, if it was standing vertical, obviously this would struggle because this thing is sticking, because it got the spindle sticking down so far. But if it was sticking up and we were using those indexable cutters, or even a solid one for $100 a piece, obviously if the Seiko was like $200, I would probably invest in that, and then just buy cutters over time when they dull out. Because if it's $50 every time I have to replace a cutter instead of $100 for the whole disc, because they do have other solid disc ones that are pretty nice. Also, I would have to machine my own little center pin and put in a keyway, because they have a keyway is basically what spins it, and then double nut it on one side, nut it on the other side, and hold it straight, and then put it in a regular BT30 or BT40 collet for use on that drive head. So that would also be nice. So we'll see. So, and obviously what that brings up is because now I have the idea of using two cutters, I have a tool change in the process. So I have one for cutting the outside, and then one for going around and cutting the teeth. Unless I get a certain diameter where all my radius... No, you can't, because the teeth are straight. You're not going to be able to cut it with that big of a disc. So you do have to come around with a smaller end mill and touch it all up. And it's going to have to be a really, really long end mill. Otherwise, I'm going to have to flip it over in order to do everything else. So this might be a longer, more involved process, but I think it has a higher chance of success, and it has a better machine that will result from it. So something similar here to the Skyfire. So yeah, So on parts, one of my friends, he gifted me this kind of this thing that he was going to throw in the trash, which was basically a weed whacker, motor, DC, regular DC motor. That is, it is what's it? It is It's a 1 horsepower DC motor. Super cool. I think that would also work starting out with the regular power head I showed you guys, the green power head. So I think that would work pretty nice as well. And then eventually I would probably step up to a what is it called? To run those DC motors, the big what is it called? The a regular DC spindle, big DC motor that I could use on this guy to basically do all of my so I could do rigid tapping and stuff. So I have very, very little assembly, so I could rigid tap the top, the sides, and the front, and do milling. And obviously with that, when I tap it, I'm going to have to put a different cutter in it. So there's 3 tool changes to do this machine. Before it was going to be, obviously on the other one, it was going to be a single tool, but obviously that single tool has, massive amounts of travel with it. So it's got to go a really, really long way, and it's a machine with less rigidity. I'm going to say maybe half the rigidity, even if it was built as I showed you guys in that video, with a spindle that can't take as much force as that power head. Yeah, so basically there are a few things with it that would be an issue. Mainly it's the rigidity. I don't think that the build volume is a problem, but I definitely wouldn't build it for outside of the shelf. That would probably only be a VMC, like the one I'm talking about here. So this is kind of just getting my thoughts out on the table. So basically what these 2 videos are going to be is to check the feasibility of these 2. So I'm going to finish the design for both, and then I'm going to price it out in video, and then get a big thing on Trello of all the prices, compare the prices. Then maybe we'll do a video on the cam, compare the cam times for both projects, and see how much benefit we get from the VMC. Obviously, VMC versus the DIY metal router, and see the benefits. Obviously, I've said a few, right? The benefits are the rigidity of the VMC, and also being able to use the VMC for other things. My dad would like to have a router, but mainly just to do wood. So we could buy a Shapeoko or whatever, or even like an X-Carve or something like that. So that's no problem. Something that's made out of aluminum extrusion is perfectly fine to do wood. But something that I could do work for Applied, or do some fictive work or something like that, so that I have some sort of so that I have clients. I'll have clients on the side that I do engineering work on. I could do machine work. I could do all that stuff. So I have multiple avenues to keep the business with money in it, so that I could keep going. So obviously this one I think has a lot of good upsides that I'm very excited about and ready to get started looking at it. Whether or not I use that, or downstairs I actually have a chainsaw, an old chainsaw that has, I think it's a 3.5 horsepower motor on it. So that might be pretty interesting as well. So obviously this guy, because the run out on the power head, unless I went to an ATC power head, but then you're talking about, I think I would rather just put a power drawbar on the power head. Just put like some sort of stepper motor or something on the power head. I'd rather just do that than do the pneumatic head, because then you're talking $1,000. I think you could do it with the power head. You're just going to have obviously higher run out, but I'm not exactly sure if even the run out that it specifies is even the run out that it has. So that is basically the what I'm thinking about. But obviously, with the smaller tools, that kind of run out's not very good. So this is mainly for larger tools, or you could use their smaller cutters, but in softer materials. Maybe not stainless because it'll just rip that tool up. Or using adaptive tool, or I could go smaller tools, but I have to do adaptive tool pass. That way, I get away with it. So that is the kind of the idea. I forgot to measure the space that this would kind of go in for a bigger one. I'll have to do that and then figure that out. Other than that, this is basically kind of the idea. The ideas that I've had for the VMC and some of the benefits of having designed my own VMC, know exactly the size, have it kind of on a discount budget, and build it for about $1,000, and be able to do these machines, but at a high density. So now at this point, it would be every time I hit the button, I do maybe 4 or 5 of these machines, let's say, right? Or well, maybe 4 or 5 might be pushing it, but maybe like 2 or 3 of these machines every time I press the button. I have a big facility plate that sits on this thing, and be able to do all of that in one press of the button. All right, so obviously the main thing is to optimize the rigidity and optimize the travels, and other than that, that's basically it. All right, so that's pretty much. I just wanted to get out all my thoughts here on this particular video. So now I could go about designing it. I have some motor choices. I have a 1 horsepower and a 3.5 horsepower AC brushed. So we could look into that as well. So this has been Steven from Legit Tutorials and Green Engineers. Thank you guys for watching the DIY metal VMC mill episode 2. And I will see you guys in the next video. Thanks for watching. Take it easy. Peace.